All right, let's look at it. So, a couple things to look at. Just looking around, and if you just look at this first one over here, when I say first one, what I consider the easiest one over here, this has no solutions to it. So if I were to look at this over here, e to the x looks like this. It goes to at a point, this would be 0, 1, and y equals x looks like this over here. They never intersect. So this has 0, all right? 0 solutions to it. Now let me erase this over here. All right, that's done. There's no solutions to it. Now, certainly looking at other, relatively easy ones, this one over here, it's a linear problem, right? Let me just quickly go through that for you. That would be 10x. I'm adding 3x to both sides. Subtract 5, you get -4. So I hope you realize there's going to be one solution over here, just one, all right? So, I'm looking around for other ones, and I got the cubic. It's probably the toughest one I have to deal with. Let's look at the secant one, all right? So right now, the secant, I know what the secant looks like. And let me just draw a picture of that. We're on letter E now. This is letter E over here. And we want to see what secant. Secant looks like this over here. And kind of tops out at, 1. I should bottoms out at 1. And then over here, sort of like it would look like this over here. It goes on forever, by the way. Something like that. And what does e to the minus x squared look like? It looks like this over here. It's really small, and then it kind of increases up, and it will hit here, and then goes back down like this over here. So just kind of looking at the picture, this over here has one solution to it. All right? Now let's look at the quadratic. All right, the quadratic may have no solutions to it, but let's take a look at it. And what do you get for the quadratic? You get x squared plus, let's see, 4x, and then you get plus 15. All right, let's see if I did that right. It's not plus 15, it's minus 15. Sorry about that. Let's see what you got there. X squared, took x from 4x, subtract 8 minus 15. Let me just look at the discriminant. All right, see if there's a root to the problem. What's that going to be? Well, relatively simple. 16 minus 4 times 1 times minus 15, which is going to be plus 15 now. Okay, has 2 roots now. 2 roots. I can cross these 3 out. All right? I'm now between B and A. So I need to look at A more carefully. And as you learn in Math 119, there's a possibility of 3 real roots for that one over there. So right now, the only thing I'm looking at are the first 2, A and B. I'm looking at this one and this one over here. I know this one has 2 solutions to it already, 2 real solutions. And I'm wondering, does that cubic have 3 roots to it? Well, let's take a look at it. And I can write down f of x, and that would be x cubed plus x minus 1. We're doing a real quick, dirty graph of that. I know it looks like this over here. I know that much. I know it has a y-intercept at minus 1. Looking at it, and certainly what I'm saying I'm looking at this over here. And when I start to realize, if I'm below 0, it's always negative, right? So what do I know about that? I'm not sure exactly what it looks like, but I know whatever this curve is over here, it can't go through the x-axis there. And over here, it's got to cross at least once. All right? Now, someone says, I wonder if it goes up and down. Well, I'm hoping you're starting to realize that, certainly if you knew more about polynomials, you might be able to use some other theorems that we know about. But right now, I notice that if x is greater than 0, what about this other thing over here? It's always getting larger. This is always getting larger. So what it means always getting larger, it's got to be doing something like this over here. So it only goes through once. All right? So this has 1 root to it. So my answer has to be B. And we're over. Done. Thank you.